So, how you doing? This is Professor Parker, and thanks for tuning in to the All This Math IG Live, where we go over math topics. All right. So today we're gonna do a couple questions. We're gonna simplify a couple of expressions, a couple of statements, rather. One is a subtraction problem, and one is a multiplication problem. All right. Now, some students look at problems like this and they immediately become intimidated because of the number of terms in the problem and the fact that there are exponents, and overall there's just a lot going on within these problems. But there's no need to be intimidated if you first know how to approach the problems and you know the step-by-step process through which you can arrive at the answer. So let's talk about number one first. So number one, first off, as I said earlier, it is a subtraction problem. All right, this is subtraction. We're trying to subtract this expression from this expression. All right. Now, what we want to do is first get rid of the parentheses. That's what we want to do first. The parentheses have a meaning. They're there for a purpose. They're there to separate one expression from the other. But once we start actually working this problem out, we're not going to need the parentheses anymore. But there's a specific way that we have to go about getting rid of the parentheses. So let's write this over. So this first expression has no minus sign in front of it. It doesn't have a plus sign in front of it either. But because there's no sign in front of it, we can assume that that's a positive expression. So when you have a positive expression overall, you really don't need, the parentheses don't really change the value of the expression. So we can simply just rewrite this expression, 5x squared minus 8x minus 7. We can just rewrite it, and I'm going to rewrite it down here. This is number one. 5x squared minus 8x minus 7. Right? Now, I've rewritten that without parentheses. Okay? Now, this next expression next to it, 12x squared minus 13x plus 9, has a minus sign in front of it. So whenever you see a minus sign, you need to be careful, because that minus sign affects everything inside of these parentheses, and it actually changes everything inside of those parentheses. If this were a plus sign, then the plus sign would not change anything. All right, it would be essentially like multiplying by positive 1. And when you multiply a number by positive 1 or a variable by positive 1, it stays the same. But here, this minus sign, it represents negative 1 being multiplied by everything inside these parentheses. All right, so you need to think to yourself, what is negative 1 times 12x squared? It's negative 12x squared. So you write minus 12x squared. I think this marker's drawn out, but we should be good though for now. Then you go to the next term, negative 13x. What is negative 1 times negative 13x? Positive 13x, because a negative times a negative equals a positive. Remember, with multiplication and division in algebra, 2 wrongs make a right. 2 negatives make a positive. 2 wrongs make a right. 2 negatives make a positive. Only with multiplication and division, though. Don't confuse the addition and subtraction rules with the multiplication and division rules. They're 2 different sets of rules. All right? Now, negative 1 times negative 13x, like I said, is positive 13x. And then this last term, negative 1 times positive 9, is negative 9 or minus 9. All right? Now that's your first step. We got rid of the parentheses. Now what we want to do is we want to look for terms that match up with each other, or like terms. It's called, some people call it combining like terms. Some people call it collecting like terms. Some people call it matching up like terms. Basically, what you're looking for now is the letters that have the same exponent. So if you identify any letters that have the same exponent, for example, I see an x with an exponent 2 right here. I see another x with an exponent 2 right here. I see an x right here, but it does not have an exponent 2. So this and this are not like terms. This and this are like terms. So what I suggest people do is draw some type of symbols or shapes, or make some type of marking around the like terms. So when you go back and you're looking for what like terms you need to add and subtract with each other, you'll be able to readily identify them. So what I might do is this. I might just draw a box around 5x squared, and then the other x squared term, draw a box around it as well, like such. So I got my 5x squared and I got my negative 12x squared. Then I look, I got, okay, negative 8x. The question I have for myself is, does negative 8x have a like term? It does, because this is x to the first power, and this is x to the first power. Remember, if you have a variable with no exponent written, or if you have a number with no exponent written, it's understood that the exponent is positive 1. It's understood, right? What's understood don't have to be said, right? If there's a blank space right there, there's no exponent, the exponent is positive 1. So I want to label this. I'm going to underline this right here. I'm going to underline that joint. I'm going to underline this joint right here. So I got negative 8x and positive 13x. And this is running out. Let me grab another blue marker. Hopefully we have better luck with this one. So I got my x's matched up. Now you might be thinking, well, how is it a like term if that's a negative 8 and that's a 13? That's cool. That can be different. Because all this coefficient tells you is how many x's you have. You got 13 x's or you got negative 8 x's. They're still x's. They're still all x's all together at the end of the day. Then you look and you say, okay, I got a constant. This is a negative 7. That's a plain number. And then I got a negative 9. That's a plain number, right? So all constants match up. All constants are like terms. So they can all be added and subtracted with each other, whether they're positive, whether they're negative, whether they're fractions, whether they're decimals. They can all be added up or subtracted with each other. They're all like terms. Constants, that is. Otherwise, if you're dealing with variables, you have to have the same letter with the same exponent. The same letter with the same little number. You can think of the exponent as the little number. This little number. This is the big number, the coefficient. That's the little number, the exponent. All right, so now I actually combine them now. So I look at what I boxed in. These two terms got boxed in. That means I'm going to combine these two. So that means I'm going to do 5x squared minus 12x squared. So I think about having positive 5 and then subtracting 12. So 5 minus 12 is negative 7. So I got negative 7x squared. So these two are gone. I dealt with these two. They combine to become negative 7x squared. Then I look at my x's. I got negative 8x. And what else did I underline? Boom, positive 13x. Now, the reason that I recommend using symbols or drawing circles or rectangles or putting check marks above things is because these problems have a lot going on. And it's very easy to leave something out. It's very easy to incorrectly look at something. The symbols that you include reduce the likelihood that that will happen, right? So anyway, I got negative 8 and I got positive 13. Now, negative 8 plus 13, what does that add up to? That adds up to negative 8 and 13 adds up to positive 5x, right? I think I might have made a mistake, though. I just thought about something. 5 take away 12 is like saying 12 take away 5. Yeah, 12 take away 5 is 7. Right, because 12 take away 4 is 8. All right, I didn't make a mistake. I thought I did, but I didn't actually. All right. So now. Right, okay, cool. I thought I made a mistake. These things happen, but I actually didn't. All right, I thought I made a mistake with this part, but this part is cool. All right, now, we dealt with our x squareds. We dealt with our x terms. Now we have to deal with our constants inside the circles. Negative 7 and negative 9. So that's like saying negative 7 minus 9. Or we're saying you owe somebody $7 and then you borrow $9 more. Now how much do you owe that person? Now you owe that person $16. All right. So that's minus 16. Now, all of our like terms have been combined. So we are finished. We did our subtraction problem. So that means that this expression, 5x squared minus 8x minus 7, minus this expression, 12x squared minus 13x plus 9, is equal to negative 7x squared plus 5x minus 16. That's the difference, right? Again, when we have subtraction problems, the result is called your difference. All right, this is the final answer. Now, let's look at number 2. Matter of fact, I'm going to write this up here. Negative 7x squared plus 5x minus 16. Boom. All right, now we look at number 2. We have a binomial. It's a binomial because it has two terms, 4c and negative 9. We got two terms, right? And this is a trinomial because we have three terms, 1, 2, 3. 3c squared minus 2c plus 6. All right, so we're doing multiplication. And we know it's multiplication because there's no sign in between. There's no division sign. There's no plus sign. There's no minus sign. There's not even a multiplication sign. But what we understand is that when no sign is written, that automatically implies multiplication. That's what that implies. It implies multiplication. All right. So what we have to do is, now some of you may know about FOIL method, right? But we can't use FOIL method here. The reason we can't use FOIL method here is because we don't have two binomials. This is a binomial, but this is not. This is a trinomial. We can only use the FOIL method, right? First, outer, inner, last, when we have two binomials. Not two trinomials, not a binomial and a trinomial, but only when we have two binomials. So let's rule that out. Basically, we're doing the distributive property, right? A bunch of times, all right? Basically, this 4c needs to be multiplied by each of these terms. Then this negative 9 needs to be multiplied by each of these terms. And then we're going to do what we did in number 1, the second part of number 1, which is try to combine or collect our like terms and match everything up that should be matched up and make the final answer nice and neat. So first we're going to do 4c times 3c squared. So when we do this multiplication, we should be careful, right? You basically want to look for your coefficient. So I got a 4 and a 3. I multiply those two first. I multiply the 4 by the 3, and that gives me 12. Draw my equal sign, it gives me 12. Then I have to multiply the variables, or you might think of them as letters. And that's fine if you think of them as letters, because that's what they are. They're letters at the end of the day. So c times c squared. Now, c times c squared, we have to apply the exponent rules. The exponent rules say that if you're multiplying two terms and they're the same base, in this case, c and c, we have to add the exponents. We don't multiply the exponents. When we do multiplication of terms, we add their exponents or their little numbers. Now, and again, if there's no exponent written, it's understood that it's 1. So this is c to the first power. This is c to the second power. So that gives us, when we multiply, a product of c to the third. All right? Now, we're done with 4c and 3c squared. We multiply those, our product is 12c to the third. All right. Now, we go next. 4c times negative 2c. So 4c times negative 2c. Again, we multiply the coefficients. Coefficients are 4 and negative 2. 4 times negative 2 is negative 8. 4 times negative 2 is negative 8. And then we multiply the letters. C times c. Again, we add the exponents. There's no exponent written here. There's no exponent written here. So that means those exponents are understood to be 1s. So you do the simple addition of 1 and 1. So what's 1 plus 1? Is 2. So this should be c squared. Then you're going to do 4c times 6. Now, usually we do number times number and letter times letter. But in this problem, this 6 don't have a letter. That's fine. We can still do the multiplication. We're going to multiply the numbers. This coefficient of 4 times this 6. The big 4 times the big 6, which gives you 24. And then you say, oh, but what do I do with the c though? Right? I don't have a letter to multiply the c by. The c is still in the mix. It's still going to be part of your product. It just doesn't have any other c to be multiplied with, but it's still going to be there. You can't just drop it off or get rid of it or leave it. It's still going to be adjacent to the 24. So 4c times 6 is 24c, because really what you're saying is, I got a 4c right here, and now I'm multiplying it by 6. So what if I did 6? What if I had a 4c 6 times? I would have altogether, I'd have 24 c's, right? So now I'm finished multiplying the 4c by everything in the other parentheses. Now I need to multiply this negative 9 by everything in the other parentheses. So now I'm following the same steps. I'm going to multiply negative 9 by 3c squared. Then I'm going to multiply negative 9 by negative 2c. Then I'm going to multiply negative 9 by positive 6. And I'm going to just write my products in a row after these three. So at first I had 1, 2, 3 terms. Now I'm going to have 6 altogether. I should have 6. I should have 3 more, giving me a total of 6. Because I got the product of multiplying by this, this, and this, which gave me that. And then I'm multiplying by this, this, and this again, which will give me another 3. So I should have 6 terms altogether. And then I'm going to start simplifying for real. So negative 9 times 3c squared. See, we got the similar situation to when we had this times this. So your big numbers you multiply together. Negative 9 times 3. That is negative 27. Negative 27. Now, there's no c attached to this 9, but that's cool though. You got a c squared right here. The c squared is just gonna be part of the product. It's gonna be in the answer. It's gonna be part of the product. So you just write the c squared next to the 27, or the negative 27 rather, because it's not a positive 27. It's a negative 27. And we also need to get into the habit of saying the word negative out loud. Say the word negative out loud. Get into the habit of that. Because negative 27 and positive 27 are not the same thing. And if you just say 27, you're not saying negative 27. They're not the same thing. So you need to be precise when you're talking through these problems and you're explaining your work. All right, so now, then we do negative 9 times negative 2c. Negative 9 times negative 2, remember, multiply the big numbers, right? This is a constant, this is a coefficient. Negative 9 times negative 2 is positive 18c. Remember I told you, with multiplication, 2 negatives yield a positive product. Remember, 2 wrongs make a right in multiplication and division in algebra. All right? Now, last but not least, negative 9 times positive 6. We need to know our multiplication facts. We need to know our 9 times tables. 9 times 6 is 54. But a negative times a positive gives me a negative. If my signs are different and I'm multiplying 2 numbers or 2 terms, my product will be negative. The same thing goes for division. So I have negative 54. So now I got my 1, 2, 3, 4, 5, 6 terms all laid out. And now I need to look for like terms. All right? So I need to look for like terms. So what I'm going to do is I start to the far left. I got 12c to the third. And remember, like terms have the same letter with the same exponent, or the same letter with the same little number. So I have c to the third power. I don't have nothing else with c to the third power in it. So that means 12c to the third is all alone. It's by itself, right? It's like a social loner, right? It's in the mix with everybody else, but it's by itself though, right? It's not going to match up with any other term, all right? But then I go to negative 8c squared. So now I'm looking for another term that's got a c in it with an exponent 2. This is not it, because that's c to the first. Here we go right here, c to the second. So what I'm going to do is I'm going to label this. I'm going to label it. I'm going to draw a box around my c squared term. So I got my c squared right here and c squared right here. All right? And then I look at the 24c and I say, okay, well, what else do I have? Do I have another c to the first power term? I know it's not that one, but I got one right here. I got 18c. And then I'm going to do this. Underline that, underline that. It don't matter what symbols you use. You can use whatever symbols you want, just as long as you're able to identify the like terms. So I got 24c and I got 18c. And then I got, last but not least, I have negative 54. That's a constant. That's a or what you might call a regular number or a plain number, right? There are no other plain numbers, no other constants, meaning numbers that don't have a variable attached to them. So that means that negative 54 stays alone, right? All right. Now, time to write the answer. So we know that, write your equal sign. We know that 12c to the third is part of your answer. Or you might call it 12c cubed. That's cool too, right? Then your c squared terms, you need to combine those. So negative 8 minus 27. What is negative 8 minus 27? Negative 8 minus 27 is negative 35. So that's going to give you negative 35c to the second. Now, here's another thing I want to point out to you. When you do addition and subtraction with variables and exponents, the exponents never change. The exponents only change when you're doing multiplication and division. See, we have to be very clear about the difference in the rules when we're dealing with multiplication and division versus when we're dealing with addition and subtraction. We have to be able to differentiate between those two different sets of rules. When we're adding or subtracting, the exponents do not change. So you should not make this do the negative 8 minus 27 and get negative 35 and then say, oh, well, let me do this. Let me do c squared and c squared. So that's 2 minus 2, giving me 0. So c to the 0 power. No, that's wrong. The exponents never change with addition and subtraction. The exponents change when we're doing multiplication and division. Remember that. Write that down. All right? Put that in your notes. Commit that to memory. Then we go to the c terms. You have 24c plus 18c. So we have 24 plus 18. Now, 24 plus 18, I could do 24 plus 20 and then back off 2 or subtract 2 from that. 24 plus 20 gives me 44. 44 minus 2 gives me 42, right? Now, I add 20 because 18 is close to 20. And it's easy to add 20 to anything because all you're doing really is adding 10 2 times. You're doing 24 plus 10 to get 34. You're doing 34 plus 10 more to get 44. 18 is 2 less than 20 though. So once you get to 44, you got to remember to subtract 2 to get your 42. So 24 plus 18 is 42. And that's just a little addition trick. You know, it's plenty of them out here, right? All right. Now, so 42c. Now, I dealt with these c squares. I dealt with these c's. I dealt with the c to the third term. Now, all I got to deal with is this negative 54. And yes, negative 54 and minus 54 mean the exact same thing. There's no difference. All right. So now, we combined all our like terms. All our exponents are different. All our variables are the same, but they have different exponents. So therefore, we've combined our like terms, and we have completely multiplied this binomial by this trinomial. And this is our final answer. So these are the two problems that I wanted to go over today, which are also a staple of algebra, knowing how to add and subtract polynomials, and also knowing how to multiply polynomials. So thank you for tuning in. And again, if you have problems that you would like to go over, I know some of us are on spring break right now, but I know things might turn up a little bit starting next week. But if you have problems that you would like going over, send pictures of those problems to the All This Math DM, and your problem may be the featured problem of the day when I go to the board. All right, peace.